Hello everyone, welcome to today's video. In this video we will be talking about sorting using Java, and in today's video explicitly we will be talking about BubbleSort, which we will see with how to implement using Java. So before going into BubbleSort, we have to understand what is the sorting process. So talking about sorting is actually a process of arranging the data in some logical order. So, if we are arranging the data in ascending or descending order, we essentially mean that we are arranging it in a logical order or in a manner in which it is well represented. So, in case of numeric values, logical orders may be uh, either in ascending or descending, whereas alphanumeric values, okay, if we are talking about alphanumeric values, they essentially mean that it can be in the dictionary order. Generally in dictionary we see it in a chronological manner, so it is, if it is displayed in a dictionary order, then we call it as a sorting. We can call that those values to be in a sorted manner. So now coming to the point of discussion for today, which is bubble sort. Okay, so before that let me give you an example. Suppose I have values like, let's say, 50, 25, 45, 80, and then 15. So if I'm representing this in this manner, 15, 25, 45, 50 or 80, or I'm representing this in 80, 50, 45, 25 or 15, we call these numbers to be sorted. Similarly, if I have certain strings, let's say A, B, C, then let's say I have Z, B, C, then I have M, A, let's say I have then H, B, O. So all these strings, if I'm arranging it in this manner, A, B, C, H, B, O, M, A, and Z, B, C, so this is something which will appear in a dictionary fashion. That means A, H, M, and Z. So they occur in a very sorted manner. So we, or the vice versa, or if I'm considering the reverse way also, then we consider that these values are sorted. Now let us discuss about the bubble sort. So bubble sort is one of the simplest sorting algorithms which is used to sort. Apart from bubble sort, we have several other sorting algorithms which we can execute, which includes, of course, the first one being bubble sort. Then we have insertion sort, we have quick sort, and let's say we have merge sort, heap sort, etc. So these are some of the widely used sorting algorithms which we can make use of while we want to sort, we want to represent something in a logical manner. Bubble sort, often it is talked about as a sinking sort algorithm, sinking sort algorithm, and this is referred to as a sinking sort algorithm because it is a comparison based algorithm. So talking about bubble sort, it is a comparison based algorithm. So actually this comparison happens in pairs, where we will compare each pair of adjacent items and we will swap them. Swapping also happens here. Swap the values if they are in the wrong order. The pass through the list is repeated until no swaps are needed, which indicates that the list is sorted. Now, for example, if I take certain values like, let's say 37, 20, 20, then let's say I have 29, then 13 and 6. So these are some values which needs to be sorted. Now what happens in bubble sort is comparison between adjacent pairs is done so that whichever number is bigger than the other. Okay, so if the order is not in the correct way, that means if I'm considering first pair, so 37 and 20, so if my aim is to represent them in the ascending order, 20 should come first, right? So if that means this particular pair is not in the order, so what we will do, we will simply swap the values of the numbers and represent this in this manner, and this will continue until no swapping is needed for the entire list. So bubble sort, we will simply swap the adjacent numbers if it is not in order. Now let us look into details how it is actually done. So suppose I already talked about the numbers. We have 37, then we have 20, then let's say we have 29, then 13 and 5. Now our aim is to represent them in an ascending order. So when it is represented in an ascending order, so this is the scenario. Okay, so when it needs to be represented in an ascending order in the first round. Okay, let's say in round 1, the first two numbers are evaluated. So 37, 20, 29, 13 and 5. So the first two numbers are evaluated. Now it is not in the order, hence 20 will come first. That means the numbers are swapped: 37, 29, 13 and 5. Now in the second iteration, 37 and 29, they are compared. They are not also not in the order, so they will be swapped, which is 29, 37, 13 and 5. Again 37 and 13 would be compared, which is again not in order, so 20, 29, 13, 37 and 5. After that the last two values would be compared, which is 20, 29, 13, 5 and 37. So the first aim would be to transfer the highest number or highest value to the last position. So once the last position is reached, that means all the elements are evaluated, the round 1 will finish its execution. So in round 2, what happens is we will get a list which is 20, 29, 13, 5 and 37. In this scenario again the same thing will be repeated, and since both of them are sorted, nothing will happen here. So 29, 13, 5, 37. Now again these two numbers would be checked. They are not in the order, so they will be swapped. So 13 will come here, 29, 5 and 37. Again 29 and 5 will come here, so 20, 13, 5, 29 and 37. Now again 29 and 37, they will not need any kind of swapping because they are already swapped. Okay, so these two, the next highest value comes to the second last element. Okay, now talking about round 3. So when round 3 is there, we have already a list which is given to us: 13, 5, 29 and 37. So first two numbers are checked, they will need swapping. So this is the scenario: 37. Again these two numbers are done, then 13, 5, 20, 29, 37, and these two numbers again will not need any evaluation because the third highest number is already shifted to the third last element. And the fourth and the final round, if we consider, so 13, 5, 20, 29 and 37. So here this will be compared and it will be swapped, and finally we get a sorted list in round 4. So when I'm consider this rounds and the number of rounds required to sort the elements, so this basically follows a particular pattern. That means if I am having the number of elements as 5, the number of rounds required is 4. Okay, so it is always the length minus 1. Okay, so 5 minus 1, which is 4, will be the number of rounds that needs to be there while performing a bubble sort algorithm. Okay, so this we will see this with a program, but before that let us analyze it through a code. Okay, through the code which we need to implement. So first of all, I have to create an array, so we will be using array concept here. So let me declare an array which is 37, 20, then we have 29, and then we have 13 and 5. So these are the values, yes, 29, 13 and 5. So these are the values that we need to sort, and we declared them into an array. After that, let us create a for loop. For int equal to 0, int I is equal to 0, I less than a dot length, and then I plus plus. So this particular loop will be for the number of rounds. Okay, now again I will be introducing another loop which is int j is equal to 0, j less than a dot length minus 1, and then j plus plus, right? So this basically, this loop will take care of the two adjacent values. Now it will be comparing that if a of j is greater than a of j plus 1, then temp, we will declare a temp variable. Okay, so int temp, and in this temp variable initially we will be storing the value of j, and then a of j is equal to j plus 1. Now initially suppose int of a of j is pointing to this location, so this value will basically be stored in temp. So temp will have 37. Okay, then in a of 0 what I'm storing is 20, and which is basically the j plus 1, and then what I'll do is I will simply move a of j plus 1, the value of temp will be shifted to j plus 1. That means a of 1 will be replaced with 37. So we will see this, but not now. So let me just rub this off. First let me write down the code here so that we do not have to bother about much about our outputs. So this is what the loop will do, the second loop will do. Now let us analyze this program first. Okay, so this is very simple, and this is a very simple block of code for sorting an integer array. Okay, now let us consider the values. Okay, 37, 20, 29, 13 and 5. So what happens is initially I is equal to 0, I less than a of length, so 0, I value is 0, then I is less than a of length is 5, yes, so it will move to the next loop where j is equal to 0 and 0 is less than a dot length minus 1, which is 4. Okay, a dot length is 5, so 5 minus 1 is 4, yes, so it moves inside the if condition. Okay, so Now what happens is, initially a of 0 is this, then a of 1, a of 2, a of 3 and a of 4. Okay, so now what I'm doing, I'm introducing a temporary variable, right, where I'm storing the value of the first a of 0, that means a of j. Okay, then in a of j, I'm storing the value of a of 1, which is 20, and then in a of 1 I will be storing the value of 37. So what happens, this will swap the values of 37 comma 20 into 20 comma 37, and once this is done, the value of j would be incremented. So now j will become 1, j is less than 4. Okay, so this condition will repeat again until and unless all the elements are scanned, until and unless all the elements are scanned. Now here what I can do is, since I am using this condition a of length minus 1, okay, if I am using this condition, that means every time the scan will take place till the fourth position, till the fifth position, which is a of 4. Okay, now in that case, we if we want to reduce the time, I can introduce one more factor here, which is minus I. So if I am writing this condition, which is a of length, let me write it in different color. So suppose I am introducing this condition as a of a dot length minus 1 minus I. What will I do? I am simply removing the last position to be analyzed. That means, what will be the condition? For the first one, this will remain as 4. Okay, for the second loop to execute, this will become 3, because I will become 1. So a of length minus 1 will be 5 minus 1 minus 1, which is 3. For the third iteration, it will be 2, and for the fourth iteration, it will be 1. Okay, so when it is getting sorted, basically what was our aim? Our aim was to move the first number to the last position, which is a sorted position for this particular number, right? So I do not need to evaluate this particular position now. I need to scan only till the other numbers are sorted. Similarly, in the next iteration, after 29 comes here, I do not need to sort these two numbers, because they are already sorted and I do not need to check also. So hence my search time will be reduced significantly if I am introducing this I factor here. Okay, and there is one more condition which we can apply in a conventional bubble sort algorithm. That means, suppose sometimes what happens, if the number of rounds are still there, or if there are number of rounds which are existing, but before that the array might get sorted. Okay, so at that point of time, it is no point that we go on sorting the array again and again, or we further go ahead with sorting of that array, right? For that purpose, what we can do is, we can simply introduce a flag variable. Okay, so initially I will declare int flag is equal to 0. Okay, and here let us mention that int flag is equal to 0, and in our program let us mention that flag is equal to 1. Okay, so what happens is, this condition, if the number needs swapping, then flag will be set to 1. if the numbers do not need swapping, which is the condition that the numbers are already in a sorted manner, then the flag will be set to 0. Okay, now here we can write a condition that if flag is equal to 0, then we will simply break out of this particular loop and we will come out of the program. Okay, so we do not need to sort the already sorted numbers. We do not need to go on checking the already sorted numbers. Okay, so this is how we basically execute a bubble sort. Even if we do not use these conditions as well as this condition, the simple bubble sort logic which you have already done in your C programs, as well as today also we saw, the simple bubble sort condition would also work fine or give you the result. But it is just that in order to make our program more efficient, we will be using we will be restricting the search space, or we will be reducing the search space, and our output that will be generated will be at a very faster will be very in a very fast way we can get the output. Okay, now this we have talked about an integer array. Now what if we use a string array? Okay, in order to use a string array, everything will remain same apart from the fact, suppose let us say that we have an array string a where it is mentioned a, B, C, then let's say P, Q, R, and then let's say Z, A, B. Suppose I have this string array. So what I'll do is I will use a method which is compare to method, and it is a very useful method when it comes to string comparison. Okay, so we will use this compare to method in order to find out the relation between two strings. So what compare to method basically does is it will compare the two strings lexicographically. Okay, so lexicographical comparison is done. Comparison is done. So that means each character of both the strings is converted into a Unicode value for comparison. Each of these characters will be converted into its relevant Unicode. Okay, and if both the strings are equal, then this method will be returning a 0. Else if it is, it returns a positive value or it returns a negative value. So if it is greater, it will return a positive value, and if it is lesser, it will return a negative value. Right? So if A, B, C is lexicographically greater than P, Q, R, then it will return 1. Otherwise, it will return -1. And in case if both of them are equivalent, then it will return us with a 0. We will also see how this works. Okay, so if I'm considering the same program that we did it for integer array, nothing changes here apart from the fact that I have to make changes in the initial part. That is, I have to write string here. And second is I have to declare the string array. So I have to declare the string array here. Let me declare it as, let's say, ABC, PQR, and ZAB. And then I will use the method which is here, that is compare to. So the method will be used here. Okay, so A of J dot compare to, and here I will write down a of j plus 1. And what should it return? It should return me with a 0 if both of them are equal, and 1 if one is greater than. So the aim is to find out whether this is greater than this, so it will find out using this condition. So if it is greater than 0, that means it will give us 1. That means first string is greater than the second string, and it will enter into the swapping code. So this is all about how we can do bubble sorting using Java. We will also see this entire thing with the help of a program. But we have to understand that in order to swap two numbers, we have to make use of the different iterations it will have, the length, and if we want to reduce the search space, we have to modify the condition up till which the search would take place. So that is all for this video. Thank you.